Greetings, Internet users. Throughout history, eclipses have caused admiration and fear. During lunar eclipses, the moon takes on a dark red color. The celestial mechanism behind it was not known precisely, and it was often attributed to impending catastrophes. In solar eclipses, the term abandonment comes from the Greek expression, as it was believed that the sun abandoned the earth. Aristotle already predicted that eclipses were due to the moon's shadow over the sun during a solar eclipse and the earth's shadow over the moon during a lunar eclipse. This supported the idea of the Earth's spherical shape, since otherwise, eclipses wouldn't present those curves in the celestial bodies. The Earth was just as spherical as the moon. From the year 1605, Johannes Kepler was able to provide the first scientific explanation of the phenomenon with precise data. Solar eclipses are one of the most spectacular phenomena that the nature of the universe can offer us. From the vantage point of planet Earth, we witness the transits of the sun and the moon as the moon gradually covers and blocks its light, leaving only the solar corona, which is the sun's outermost atmosphere. It is astonishing that the moon, being 400 times smaller than the sun, can completely eclipse it. This happens because the moon is also 400 times farther away from the sun, making it appear to be the same size, an astonishing coincidence that allows us to witness this spectacle. Solar eclipses usually occur during the new moon phase, when the moon is fully facing away from the sun and passes through the sunlight, thus eclipsing it. Due to the large distance involved, a solar eclipse cannot be observed throughout the entire planet, but only in a small area where the moon's shadow is projected. In that specific area, the three bodies, the Earth, the Moon, and the Sun, are aligned, and nightfall will be seen for a few minutes. The Moon's shadow that reaches the Earth's surface is divided into two parts, the umbra and the penumbra. The umbra is the darkest part of the shadow, and an observer in that area will witness a total eclipse. The penumbra is the outer, lighter shadow and is seen as a partial eclipse, depending on the alignment of the Sun, Earth, and Moon. In addition to the distance, different types of solar eclipses can be observed. We highlight the total solar eclipse, when the moon completely blocks the sun, and only a small portion of the Earth's surface can witness the phenomenon. The annular eclipse occurs when the moon doesn't fully cover the sun. This happens because the moon's elliptical orbit around the Earth is not always at the same distance. Thus, when the moon is slightly farther away from us, it is at its apogee, and its disk will not completely block the sun. A partial solar eclipse occurs when the umbra does not reach the Earth entirely due to the peculiar movement of the orbit. The celestial bodies are not fully aligned, and we can only see the moon darkening a portion of the sun from our perspective on Earth. However, eclipses also occur in space depending on your position. This happened during the Apollo 12 mission in November 1969, where the crew was able to witness a solar eclipse caused by the Earth, not the moon. It is important never to look directly at the sun during an eclipse, as it can harm your eyes. The best approach is to use approved eclipse glasses, which can be found at optical stores, or use welding filters with a rating of at least 14. There are indirect methods, such as projecting light onto a white cardboard through a small hole in a covered mirror. Always look at the cardboard, meaning the projected light, and never use X-rays, CDs, or water for projection effects. During a total solar eclipse, the outermost part of the sun's atmosphere, the solar corona, can be seen and studied. It takes on spectacular shapes and is composed of plasma. Even the classic solar flares can be observed. At that moment, day turns into night, and the temperature begins to drop. Many animals become disturbed without knowing exactly what is happening. It was not too long ago that eclipses also disturbed us until we were able to study and understand them. Eclipses only last for a few minutes, and afterwards, everything returns to normal. Eclipses are also a good opportunity to test Einstein's theory of relativity. The study of stars near the sun shows changes in their positions due to the curvature of spacetime. Since light must pass through a massive object like the sun, the eclipse provides a unique observation. Lunar eclipses are not as visually spectacular as solar eclipses, but they are equally beautiful. The advantage is that they occur more frequently, at least 2 per year, and can be seen without the need for protective equipment from various locations on the planet. Lunar eclipses occur when the Earth comes between the sun and the moon, with our shadow covering the moon, resulting in a change in its color, typically to a reddish hue. Lunar eclipses can be observed from many other places where it is nighttime and can last for at least 2 hours. Unlike solar eclipses, which last only a few minutes, when the Earth passes between the sun and the moon, it blocks the sunlight and creates two shadow regions, giving rise to various types of eclipses. Penumbral eclipses occur when the moon only passes through the penumbra region, a part of the shadow cast by the Earth. During this phase, the moon's brightness decreases very slightly. Partial eclipses occur when the moon does not enter the shadow region completely. Part of it is in the umbra and part in the penumbra. A portion of the moon becomes darkened in partial eclipses. In total eclipses, the moon follows a path that takes it into the Earth's umbra, causing the moon to darken and take on brownish and reddish hues. The color the moon may acquire during an eclipse is unpredictable and depends on various factors, such as the state of the Earth's atmosphere at that moment, including factors like fires, volcanic eruptions, and pollution, among others. We can witness very dark eclipses where the moon is hardly visible. The blood moon is the most common, as the Earth's atmosphere scatters blue wavelengths and refracts red ones, resulting in a reddish tone for the moon. In dark eclipses, the moon can also take on grayish or brownish tones, rust-colored hues, orange tones, and even a turquoise-colored border. Finally, there are brick-red eclipses where the moon appears red with yellowish edges. Eclipses are not exclusive to our position on Earth. Alignments of planets in the solar system give rise to different occultations. This can occur with various planets, such as Saturn occulting Jupiter, or planet transits in front of the Sun, like Mercury. Satellites passing in front of planets, such as Jupiter, can be observed through a telescope as small dark spheres crossing the planet. In fact, one of the methods for discovering exoplanets beyond our solar system is to observe variations in the brightness of a star, which indicates that a planet has passed in front of it, similar to how Mercury passes in front of the Sun. However, due to their greater distance, the difficulty of observing them increases, and the exoplanet cannot be seen. We only observe the attenuation of the star's light. If an additional amount of light is observed attenuated by the star periodically, it indicates that the planet has an exomoon. This method is still under development and will allow for the detection of more exomoons around other planets. Eclipses can be different from those seen from Earth and even more spectacular. Let's travel to the Kepler-47 system. Kepler-47c is a planet located in the habitable zone with two suns, a yellow dwarf and a red dwarf, and every 7 days, one partially obscures the other. Additionally, we could periodically witness the gas giant Kepler-47b partially obscuring the star. If we were on the planet Kepler-47c, we would call it a planetary eclipse, a cosmic spectacle worth witnessing. Eclipses are beautiful phenomena that are worth experiencing, and the types of eclipses we can witness throughout the universe depend on our position and the distance between celestial bodies. If we were explorers traveling through different planetary systems in the universe, we would encounter various types of eclipses, especially on satellites with gas giants and multiple suns. We would see stars and planets being occluded many times. By freeing ourselves from our home planet and crossing the vast regions of space, we would discover that eclipses are not strange occurrences, but rather depend on the distances between celestial bodies. A spacecraft could act as a planet and position itself in the umbral zone to witness beautiful views. This event, which was exceptional, mystical, and even catastrophic for us just a few hundred years ago, would become quite common for future space explorers. However, even within our solar system, we are missing out on great celestial beauties. If someone were on the moon during a lunar eclipse and looked towards Earth, they would see a solar eclipse. The projected light from Earth would appear with a deep reddish tone, and the surface of the moon would be dark and red, a remarkable phenomenon that only future colonizers will be able to witness. If you enjoyed the video, give it a like, share it on social media, and subscribe.